Hello everyone, hope you are doing well. I'm Reza Mohammed Hassanin, the founder of the optimizationcity.com. In this presentation, I'm going to learn how to use the online solver of the dual simplex method in the optimizationcity.com. Let's start with an introduction. The dual simplex algorithm is one of the best methods for solving the linear programming problem. To solve the linear model, Simplex or GAM software has been implemented, but to solve the linear programming model with this software, they must be installed on the client. And for the larger model, a valid license must be available. In order to make solving the linear programming model simple, the Optimization City group has designed and developed an online solver for solving the linear programming problem. In the following, we will review how to use the online solver. This is the GUI of the online solver for dual simplex method as follow. The enter data is as follow. Here I just present n is the number of decision variable, m is the number of constraint, esp is the maximum acceptable error in the calculation, a is a matrix that has m plus 1 row and n plus 1 columns. The first row is the coefficient of the objective function, and the first column is the right hand side and the other are the coefficient of the functional constraint. 3 points I should mention here. First, the component of the matrix out can be continuous number. Second, the desired model should be in standard form of the dual model. Each limit has a basic variable, only one. And the last one, the coefficient value of the variable in the objective function should be negative for maximization. Okay, let's solve an example. Consider the following model. We are going to maximize the objective function here with the 3 constraint and the 7 variable. Each constraint has a one basic variable. In the first constraint, x5, in the second constraint, x6, and the last constraint is x7. The input information for the model is as follows. N is the number of variable is equal to 7. M is the number of constraint is equal to 3. ESP is the maximum acceptable error. And this is the matrix for coefficient. The first row is the coefficient of the objective function, and the first column is a coefficient of the right hand side, and the other is the coefficient of the variable in the functional constraint. So let's go to the website and see how to use this data for solving the dual simplex methods. Okay, let's go to the website. This is the website calculator operation research solver, and go to the dual simplex methods. N is equal to 7 is the number of variable, M is 3 is number of constraint, ESP is 0.00001, and A is the coefficient of the objective function, functional constraint, and right hand side. I entered before here. You just click the run and you can see that the output section. In the output section, the phrase optimal solution found means the model has a limited optimal solution. In the output, it reports only the variable, the value of the basic variable. So we have 3 basic variables here, and the rest variable are equal to 0. In this example, the optimal value of the variable are x1 is 0, x2 is 10, x3 is 0, x4 is 1, x5, x6 is equal to 0, and x7 is equal to 2. The optimal value of the objective function in the last phrase of this output is equal to minus 36. Well done. Thank you so much for watching us. If you have any question, you can send an email by optimizationcity@gmail.com, or you can fill out the contact form in the optimizationcity.com. Thank you so much and goodbye for now.